Imagine for a moment that you are in the vacuum of space. You have a stone in your hand, and you swing your arm with all your strength and throw it. The stone first moves away quickly, then starts to slow down, and finally stops as if it has hit an invisible wall. Wait a minute. This could make Newton turn in his grave, because everything we have learned so far told us that Newton's first law says, an object in motion continues its motion unless a force acts on it, didn't it? And as far as we know, there is no friction in space anyway. So why is this stone slowing down? Where is all this energy disappearing? This seemingly simple question challenged even Einstein, one of the greatest geniuses of the 20th century, for years. Because the answer was not hidden in Newton's classical laws, or in that famous E=mc² equation, but somewhere else. And that answer was given by one of the greatest mathematical minds in history, Emmy Noether. This story is not just about a stone stopping in space. It is the story of a human trying to understand how the universe works, encountering a mysterious answer coming from the depths of the universe. In the early 1900s, while Einstein was developing the general theory of relativity, he faced a major problem: the conservation of energy. In classical physics, energy is always conserved. But in Einstein's new model of the universe, where space-time bends and curves, things were getting complicated. The answers he gave to the question of where energy goes were mathematically insufficient. His answers did not conform to general covariance, one of the fundamental principles of general relativity. So much so that the energy equation he proposed was even referred to among physicists as the so-called fake energy equation. And right at this point, Emmy Noether stepped in. You may have never heard the name Emmy Noether before, but she was a genius who changed the direction of science. Just imagine, in Germany at the beginning of the 1900s, at a time when women were not admitted to universities, she attended men's classes with special permission and studied mathematics. Despite all the difficulties, she worked tirelessly because she had big questions in her mind about how the universe functions. And while solving those questions, she noticed something that went down in history. According to Noether, if the universe has certain fundamental symmetries, these symmetries ensure the conservation of something. For example, if in space you get the same result no matter which direction an object moves, momentum is conserved. Or if the system remains the same as time progresses, energy is conserved. Or if a system does not change when you rotate it, angular momentum is conserved. And this incredibly powerful idea formed the foundation of all the laws of physics we know today. This idea was even named after her, Noether's Theorem. But now we come to the main point. What if the universe is not static, which it already isn't? The universe is expanding, and not only expanding, it is expanding at an accelerating rate. This breaks that beautiful symmetry related to time. And what Noether tells us is this: if symmetry is broken, the conservation law associated with that symmetry also loses its validity. That is why the stone you throw in space slows down, but not because of a force acting on it. Now, listen carefully here. I'm going to explain it as if I'm very smart, but believe me, you will understand too. With the expansion of the universe, the meaning of the stone's motion spreads into space, as if its energy mixes into somewhere. The stone is actually still moving, but this motion no longer has a measurable counterpart as energy. So energy does not disappear, but it is not conserved in the classical sense either. This was such a revolutionary insight that it not only solved Einstein's dilemma. Today, from particle physics to black holes, from electromagnetic interactions to quantum field theories, the symmetry idea of Noether lies at the foundation of everything. From why an electron does not lose its charge to why the Higgs boson gives mass, everything is under the influence of this theorem. And now think. The person who discovered this was a woman who had to flee Germany because of the Nazis. She taught at a small women's college in the United States. Even in the final years of her life, she continued to give lessons at her home. Even Einstein said this about her: the most important creative mathematical genius to emerge since the beginning of higher education for women. In short, Newton is not exactly wrong. Yes, energy is conserved, but only under certain conditions. In everyday life, we do not feel the expansion of the universe. Our car does not stop if we do not brake. If we throw a ball, it flies. Because time symmetry is still locally valid, but on the scale of billions of years, that is where things change. Energy seems to blend into the fabric of space. That is why when you throw a stone into space, it appears to stop. But that stone actually whispers to us how strange and magnificent the universe is. And Emmy Noether Theorem helps us decipher the meaning of that whisper.